Student. Welcome to the new course. This is distributed systems. So in this course, you are about to learn how the distributed networks are going to be communicated with each other and how the processes takes place. I mean, the applications are taking place between n number of systems, so with a proper concurrency by sharing the loads and by sharing the resources and so on. So let us move into the course in detail. Now, the first topic which we are going to discuss today is introduction to distributed systems. In this, the outline which we are going to discuss now are, first, we are going to discuss about the definition part of the distributed systems, next, the characteristics, and the third is how a distributed system will be acting as one of the middleware. And at last, we are going to close with the goals of the distributed systems, right? So let us move with our first part, that is a definition of the distributed systems. So distributed systems is nothing but it's a collection of n number of computers which are working, I mean, which are computing, but in terms of user, that will be like a single coherent system. Like the systems are n number of systems are communicating, I mean, computing at background, but to the user, it will be viewing as I am communicating to only to my system, right? So this is the view, like, I mean, the top level view of the user will be given to the one system only, but at the background, there will be n number of systems working to complete that particular task, right? And in the distributed systems, all the systems which are communicating are autonomous systems. I mean, the computers, maybe whatever the devices which we are communicating are autonomous. Autonomous means same kind of environments, configurations kind of thing, right? Now, the next point is in this, the programmers, I mean, the users may be the programs itself or is the users directly, I mean, the people directly, right? So this is a definition part of the distributed systems. Now, coming to the characteristics of distributed systems according to the given textbook Tannenbaum are four. So the first characteristic is we have to, when we are working in the distributed systems, we have to hide n number of communications or is the system devices from the users, right? So user doesn't need to whom we are communicating at the background, but in the foreground, the front end page, whatever they are seeing will be the only point which will be given to them. But at the background, there will be n number of things happening, that things which we have to keep in the hidden mode to reduce the complexity to the user level, right? The second characteristic, most important, is a consistent and uniform interaction. See, consistency and the uniform interaction in terms of providing the services. I mean, the users should get all the services without any distraction, without any faults and everything, right? So in this point, we should be taking care. Next, third important characteristic is about the scalability. See, scalability in terms of building the capacity of the resources. So at present, if we are having 90 systems in our network, I mean, in the which are communicated in the distributed system. Now, if we want to extend to 10 more systems, then that 10 more systems should be configured immediately to the existing system. So that is what the scalability in, like, we are going to extend the capacity of the resources, right? The last and very important is the continuous availability, means all the services and all the resources must be always available to the end users. The foremost aim is nothing but we should provide services to the our clients, those like users. So the users should not be distracted while they are utilizing any application. So for that reasons, all the background, like if any resource has been attacked by some any external activities, immediately that must be recovered or replaced. So all those happenings should be taking place at the background, but that should not distract the end user. So always all the services should be available to the end users. Now, the next part in this is about the middleware. See, middleware is nothing but it will be taking multiple machine inputs, but the like it will, the inputs may be multiple, but the output which is giving to the other end party will be the common interface, right? So we have n number of and as the name itself saying, it is distributed, means systems are going to shared between a number of applications, right? So when this is happening, a layer should be there which should be giving a common interface to the all the applications, right? So at the background level, see if we can see the diagram here, if you can see this diagram here, all the layers at the down network, I mean the bottom level, are having different types of operating systems over there. All the different types of operating systems may be having different types of configuration, different types of platforms, and so on like that. Now, all this clubbing together to the distributed layer, that will be giving an output to the applications as a common and same interface to all the applications above. So all the end users will be seeing same kind of environment, even though the background is something like if application A is communicated with the operating system 1 here, the environment which is provided by the distributed system layer, I mean the middleware, will be the same. And application B is utilizing internally, it is utilizing operating system 2 and 3, but the output level will be same like application A itself, right? So if we can give a common example, if we have a software in our hand, the web page of that software should be same if I'm opening that in the Mac OS, or it's if I'm opening in the Windows operating system, if I'm opening in the Ubuntu environment. So whatever the platform I'm utilizing, the web page must be common, right? So if my system is 15 inches or whatever the inches, the web page which is visible to all the users should be common and same. So in that way, the middleware will be working here, right? So the next and the last topic in this session is the goals. So what are the goals of the distributor systems? There are 6 goals listed below. The first goal is a resource sharing. Second is openness. Third, concurrency. Fourth, scalability. Fifth, fault tolerance and transparency. Coming to the resource sharing, here the resources should be evenly shared between n number of systems, right? And the openness will be in terms of the softwares or else the systems which we have in the network should be always available to be upgraded with the latest versions of the software. So if we take one software, if that software is with the first version and we get the new version with the software version 2, so that existing software 1 version should be always open to upgrade itself from 1 to version 2. So this is the main thing which should be available in the whole distributed system, right? So the systems must be that open to accept the upgrades every time, because a lot of trends are happening, right? So all the trends should be given to our systems immediately within fraction of minutes, I mean updates to be done. So for that reason, openness should be an important goal to achieve a number of things in the distributed system. Third one is a concurrency. Coming to the concurrency, here this will be divided into 2 categories. One is with at the same level, we should provide all the services to the users. If one user is writing some content, parallelly, if other user is reading the same content, the existing content should be given to the reading part of the user. While this update is happening, this update should not affect the users who are utilizing at that moment. That is one. Second end is sharing the load between all the systems evenly. So concurrency in load balancing, right? And the fourth one is about the scalability. See, coming to the scalability, it is very, very important, as we just discussed in the characteristics also, that always our system should be able to accept new resources to be added into the network, right? So expandability of the resources can be done by the scalability goal. Next is the fault tolerance. Coming to the fault tolerance, here we will be faced with n number of attacks, maybe crashes in between when we are dealing with n number of systems. So the crashing of one system should not affect the whole network or else the system itself, application itself. So thus, when we are dealing with this fault tolerance, the system should be immediately recovered, or else we have to replace, or else something action to be taken place. So for that, the fault tolerance is one of the important goal of this system. And the last one is the transparency. See, coming to the transparency, this is the name is saying that transparency means to be open to all the, I mean, all the systems should be openly given to all the users. However, at the same time, we should hide the things which are complex, makes complex environment to the user, like such as you will be having a physical environments where multiple systems are communicating with each other. So there are a number of processes and resources will be acting, right? So all these combinations should not make the user that something is happening at the background. So user must be able to just utilize the software, but unnecessary things we should hide from the user. So what we are hiding? So hiding in terms of transparency. So what transparency we are doing is, there are 7 types of transparency. So as the box is here listed, so first one is access transparency. In access transparency, we are going to represent the data which is not required to the user. So we have to hide such kind of data resources kind of thing. Next, location. See, all the time we should not give all the data like which resource is located at which place, like that. The final aim is how the user is getting the application used. That's it. But where the resource is stored and all kind of things are not necessary. So we should hide that. Migration is nothing but the movement of the resources should be hidden from the users. I mean, the relocation and migration will be looking like same, but the relocation will be at the time of the application is in use. So relocation of the resources at the time of the use. Replication is nothing but hide the resources which are backing up, or else replicated means mirror images kind of things, backups and all. Concurrence is nothing but, just now we discussed, it's about the load balancing, sharing of the data, sharing of the services and all, so that we should hide from the users, right? Failure is nothing but whenever we have n number of faults, so immediately we should be able to recover, replace all these things which are happening in the background should be hidden from the users, right? So all these are about the goals of the distributed systems. Till now, if you have any doubts, please be free to contact anytime through the comments or through the college. In the college, thank you. Take care.